Okay, another study, sir. Good afternoon, everyone. I'm Vijay Bhaskar Reddy, Assistant Professor, Department of Electronics and Communication Engineering, KG Reddy College of Engineering and Technology. And I'm going to discuss about 8086 microprocessor. And today's class, let us discuss about 8086 architecture. Okay, 8086 is a 16-bit microprocessor where it consists of a 16-bit ALU and performs all the arithmetical or logical operations of 16-bit size. Okay, and we are going to discuss the internal block diagram, nothing but architecture of 8086 microprocessor. And basically, the architecture of 8086 completely divided into two subparts based on the pipelining capacity or pipelining operation of 8086 microprocessor. The first stage of 8086 microprocessor is called bus interface unit, and basically it is consists of an added circuit and set of registers. All the registers are of 16-bit size, and these set of registers are basically called as segment registers. Okay, and this is basically an added circuit which is used to perform the address addition operation. Means to show the physical address location of memory where exactly the data is available, we will use this particular added circuit where we can add effective address and base address of the instruction, and it will locate the physical address location of the memory where the data is exactly available. Okay, right, and just observe the architecture, and this is a B bus where the data transfer takes place between like added circuit to segment registers, and these are the four different segment registers named as extra segment represented with ES, next stack segment SS, data segment DS, and core segment CS. And finally, there will be one more 16-bit register location called instruction pointer, which will give us the instruction to be executed, right? And next, the BIU also consists of a 6 byte instruction queue. BIU also consists of 6-byte instruction queue. The size of instruction queue is of 6 bytes, which will store the maximum of 6 instructions of each 1 byte, or one instruction which is of size 6 bytes. Okay, and the purpose of instruction queue is to boost up the performance or to speed up the performance of 8086 microprocessor. Okay, right, and now let us see this complete BIU internal structure of 8086 microprocessor. This is basically a complete BIU process, and then after instruction queue, the instructions of the program will be either decoded through control logic if required, and the decoded form of instructions directly will go to the next section called execution unit, where we will find a bus, a big internal bus called A bus. That we will discuss in the case of next section EU. And this whole part of microprocessor 8086 architecture is called as bus interface unit. Now let us discuss in detail one by one. Yeah. As 8086 microprocessor is a 16-bit microprocessor, consists of 16 address data lines, 16 data lines, and 20 address lines. 20 address lines. And it's having 20 address lines, then the memory capacity of 8086 microprocessor is 2 power 20, that is equal to 1 MB. So, a maximum of 1 MB of memory can be accessed by 8086 microprocessor, where we can store the data like program code words and instructions, or if the temporary data or resultant data, and data required for the running of program, or etc. etc. Okay, that is stored by the accessed by the memory here. Next, now all the 4 segment registers are the part of memory where we have 1 MB memory. That 1 MB is again further divided into 4 segments of each the size 64 KB. Say data segment, similarly core segment, similarly stack segment, and finally extra segment, where this is totally 1 MB of memory can be divided. But if you see individually, one segment is of size of 64 KB, kilobytes of memory. And what they store data? Coming to the segment by segment, the data segment is responsible for storage of all the relevant data required for the programming and the processing of different code words and instructions. And core segment will store all the instructions or commands, also called as assembly language programming, or the ALP, which we have written for specific task. And stack segment, this is a specific or special function where it can store current execution or address location of current execution and interrupt service routine is going to execute. Stack segment is used for ISR services, and extra segment can be used along with data segment for data storage or any other purpose. Okay? Yeah, now, when you are going to write an instruction, how the 8086 microprocessor can access the particular instruction data or the code word from the memory. That is taken care by the main purpose of the circuit is adder circuit, which is present in the BIO. This adder circuit will add base address also called as segment address, because all the 4 segments here out of 1 MB we have given 64 KB segment address, and then each and every segment having its own base address. Maybe 2000 is a address location base address of data segment. Likewise, we have all the each and every segment register having its own base address. Then base address plus offset address. Offset address. What is the offset address? If the 64 KB, again if I divide this DS into the 64K locations, 64K locations are there. Each and every location having its own address location. Its own address location. So all the 64K locations within the data segment are called as offset address. For example, this is an address location, say 0005. Let us consider H. This is the address location with 20-bit address location, and this is 16-bit and this is 16-bit. When we are going to add them, it will generate a 20-bit by multiplying this as a 10. That I'll discuss now. And let us consider this is some XX data available in this memory. That data we need to use in the program application or operation while executing the program. How to access it? Simply, the adder circuit will add base address, that is 20,000. Like in 2000 multiplied with 10 will give you 20,000 plus offset address, that is 0005. If you add them, this becomes 20,000 and 5,000, 0005. If you add them, it will be H, hexadecimal. And this is the one of the address location available in main memory, which is connected to the 8086 microprocessor. Likewise, adder circuit will generate a physical address location of data or the code words available in the main memory with the help of segment registers which segment we are using, that is depends on type of data. If you are working or want to access the code words or instructions, we'll use code segment and that base address. If it is related to data accessing, then we'll use either DS or ES base address. And if it is stack operation or ISR service routine, we will use stack segment. Okay, these are the different segment registers are having different base address, and these will help us to convert the data or instructions available in the memory to access. And then this complete work accessing of data using different address location and generating a physical address location is carried out by adder circuit in the BIU section. Okay, once BIU generates physical address and gives this to the memory, then the instruction or the data present in that particular memory location generated by the physical address of adder, that will be accessed, the data will be accessed by the bus called C bus. This is C bus and B bus and A bus. We have three different bus circuits in the 8086 microprocessor. Then through C bus, the instructions or the code words one by one will be copied into instruction queue. As I said, this is a 6-byte instruction queue. The size of the instruction queue is 6 bytes. Okay, as we know, 8086 microprocessor having 2 to 6 different kind of instructions, as like arithmetical, logical, control transfer, branching, loop instructions, etc. etc. But the different instructions are of different size. One may be a 1-byte size, 2-byte size, or maybe a 6-byte size or 4-byte size. It depends upon type of instruction which we are going to use or we are defining in the program. So that at maximum it can store one instruction, 6 instructions which are of 1-byte size, or it can store only one instruction which is of maximum size is 6 bytes. Okay, what is the purpose of this? You just think about the process. When microprocessor, this adder is calculating the physical address and accessing the memory location where the data or the instruction is available and fetching that to the control unit or execution unit. For every instruction, the process is taking place like this. There might be a little bit amount of delay may exist, and the overall performance or speed of operation of the system may decrease. So, by keeping in mind what we have done here, instructions. Already the number of instructions in the order already we fetched onto queue, which are ready to decode and execute. One instruction is execution done by execution unit, automatically second will execute. Second will be fetched into the execution unit with the help of queue where there is no delay. So the speed of operation or system performance will increase. And there are, why we are using here two different pathways. One may directly go to execution and set of instruction go to control logic. There are set of instructions which are system dependable or system related or system dependable, where they are already under the form of decoding, and only set of instructions which we need to decode. Those instructions only will go to control logic and get decoded and then convert into machine level language and sent to execution unit for the execution purpose. Okay, this is the complete overview of the first part of architecture of 8086, that is bus interface unit. Okay, I think we learned here what are the different parts of the microprocessor available or exist in BIU and what is the purpose of each and every one, what they do, that we learned. And let us discuss the execution unit of 8086 microprocessor. So this processor